Now we have already understood Young's modulus and the Hooke's law. We have understood both of those two things, and the Hooke's law, as we have understood it, we have only used it in the case of springs. But the Hooke's law is more general than that. It also applies to this rod, for example. So this is the metal rod that we have used to demonstrate the Young's modulus. And even in this case, the Hooke's law is applicable as long as this metal rod is in its elastic region of deformation. Okay, so we have seen the curve of deformation, and as long as this rod is in the elastic region, that means that the Young's modulus applies. The Hooke's law also applies to this rod. Okay, so not only to springs, but the Hooke's law applies to all the other objects as well. So this is let's revisit the Hooke's law. So what does Hooke's law say? Hooke's law says that the deformation or the change in length of this spring, which is x, is directly proportional to the force which has been applied to it. So here we had applied a force of F, here we have applied a force of 2F. So here the deformation was x, and it became, as the force became twice, the deformation also became 2 times. And this is generally written as F is equal to Kx, where x is the spring constant. So this is F is equal to Kx. This is the general form of the Hooke's law. So now this was the Hooke's law. What is the other thing? The Young's modulus. So this is the deformation curve, stress and strain curve of this metal rod. So this metal rod, we have applied force F to it, and because of this its length L has changed from L to L plus delta L. Okay, so it has changed by delta L. So this is the increase in length due to the force F. And notice that we are in this region, the linear region of the stress strain curve, and because of this, the Young's modulus applies here, and Young's modulus is equal to rise by run. So rise is the stress. What is our stress? Stress is the force per unit area. And what is my strain? Strain is the relative deformation. So it is delta L by L. So this is the formula for the Young's modulus, and we will use this symbol Young's modulus. We'll use this symbol as Y. Although we can also, or people have also used it in your textbook, also E has been used. Okay, so but we will not use E, because the problem is that when the energy comes in, potential energy in this rod, for example, when we have to derive those formulas, then the symbol E becomes double. Okay, so E is for energy, E is also for Young's modulus. So we'll avoid that. We'll use the symbol Y for the Young's modulus, and in this region of the curve, the Young's modulus is equal to stress by strain, where the stress and strain are proportional to each other, which is the linear region of this stress strain curve. Okay, so now that we have understood both these things, let us try to find out the relationship between the Hooke's law and Young's modulus. Again, very important from the numerical point of view. So force is equal to Kx. This is the formula for the Hooke's law. What about the Young's modulus? The formula for Young's modulus is Y, which is Young's modulus. It is equal to stress. Stress is F by A divided by strain, which is delta L by L. Okay. Let us just also write this X as delta L, because X is of course the change in the length due to the force F, which is delta L. So in other words, I can write this as K is equal to F by delta L. Let us just also simplify this a little bit. So this becomes F by A into, this is delta L by L, so this becomes L by delta L. Of course, we can simplify this further. So this becomes F by delta L into L by A. Now this F by delta L is nothing but K. So this becomes, this is the final formula, very important. Y is equal to K L by A. If we have to find the value of K, then this will become K is equal to Y A by L. Okay? And if for Y you want to use the symbol E for Young's modulus, then by all means do that. Okay, and this is again a very important formula from the perspective of your numerical. You use this formula, you'll be able to solve the numericals 10 times easier, and we have used this. We have several numericals on DoorstepTutor. So if you are practicing from there, then of course you are all set. Thank you.